Hello and good afternoon to everyone. I'm very happy to welcome you on the first masterclass of Protect Europe project, Breaking Barriers to Understanding the HPV Epidemiology and Reaching Equity Through Gender-Neutral Vaccination. We are very happy to be with you here today. My name is Plamena Nikova, and I'm co-chair of the steering committee of the project. For me, it's really important to raise awareness about the vaccinations, especially as a representative of a country such as Bulgaria, which now has at the moment outburst of diseases like pertussis and measles, and can quite understand how a world without vaccination can be very frightening. So I think it's really important to raise in every occasion the power of the vaccination, how really important is to do as much as we can as people, as professionals. So I'm very happy to introduce you and to welcome you at this meeting today. The meeting will be recorded, and we'll be very thankful if you mute your microphones until you speak and until the floor is open. Please raise your hand if you have any questions, and we'll be very happy to have a lot of questions in the questions and answer field, and also the EU competition rules and antitrust laws applied during the meeting. So this is for me, and I'm very happy to give the floor to Dr. Beatriz Serrano, who will introduce us to her presentation on HPV epidemiology and infection rates. Please, Beatriz, the floor is yours. Thank you.
Well, thank you, and thank a lot to the ECHO and the Protect Europe for inviting me to participate in this set of masterclasses. Well, as you have said, I'm going to talk about the epidemiology of HPV and the infection rates. Please, next slide. Well, we will first begin with a brief description of the human papillomavirus and its associated pathology. Well, HPV refers to a group of viruses that belong to the Papillomaviridae family. Currently, there are more than 200 known HPV types capable of infecting humans. The different HPV types share the same structure and genome organization. Briefly, HPV contains a circular double-stranded DNA genome with 3 domains, represented in yellow in the graphic. There is the late region, which encodes proteins which are involved in viral packaging. The available vaccines are composed of virus-like particles produced by self-assembly of copies of the L1 protein, which induces the production of protective antibodies. The long control region, or LCR, regulates virus replication. And finally, in red and green, there is the early region that encodes proteins that are involved in virus replication and other activities such as the immune evasion. Next slide, please. Next slide, please. Thanks. The HPV viruses infect both the cutaneous and the mucosal epithelium. And while in this presentation, I will focus on mucosal types that are mainly sexually transmitted through vaginal or anal intercourse, and that include low-risk types and high-risk types. These last high-risk types are considered oncogenic types. Next slide, please. Well, low-risk HPV types cause benign lesions such as anogenital warts and recurrent respiratory papillomatosis. HPV 6 and 11 are identified in more than 90% of these lesions, and both types are included in quadrivalent and nonavalent vaccine. High-risk HPV types include 12 HPV genotypes that are considered oncogenic. And well, these high-risk types cause almost all cases of cervical cancer, as well as a variable fraction of cancer of the vulva, vagina, penis, anus, and certain head and neck cancer, mainly at the oropharynx. These 12 high-risk HPV types include HPV 16 and 18 that are contained in all vaccines, HPV 31, 33, 45, 52, and 58 that are contained in the nonavalent vaccine, and also HPV 35, 39, 51, 56, and 59. Next slide, please. Now we move to the natural history of HPV infection. Next slide. Well, HPV is the most common sexually transmitted infection. More than 80% of sexually active people will become infected at some point in their lives. But most of these infections, close to 90%, are asymptomatic and transient and resolve in 1 or 2 years without causing lesions. Only persistent infection with oncogenic types, the high-risk types, could eventually lead to precancerous lesions and cancer. Well, next slide. Well, in this slide, I will focus on cervical cancer because it is the most frequent and studied HPV-related cancer. Cervical cancer carcinogenesis is a long process that involves several steps that occurs at characteristic ages. In the graphic, we can see that the HPV prevalence, that is represented in blue, peaks in the late adolescence at the 20s. This is after sexual debut and when the number of sexual partners is usually the highest. Prevalence then starts to decline and tends to stabilize at approximately 45-year-old, although in some populations, a second peak of prevalence is observed in older women. The prevalence of cervical HPV infection largely depends on the sexual behavior of the population. Precancerous cervical lesions, which are represented in the graphic in orange, peak at age 30, on average 5 to 10 years after the peak of infection. And finally, represented in red, the average age of women with invasive cancer is 40 to 50 years. Next slide, please. Well, the interval between the acquisition of an HPV infection and the progression to invasive carcinoma is usually 15 to 20 years or even longer. But the reasons why some HPV infections persist and progress to cancers and others do not are not fully understood. Several cofactors may play a role in the natural history of cervical cancer. We have the viral factor, which are the HPV genotype and viral load, which is the amount of virus. The HPV genotype is the most significant determinant of persistence and progression. HPV 16 presents the greatest oncogenic risk, and we have also host cofactors such as endogenous hormones, genetic factors, and also finally the exogenous cofactors that are the tobacco use, prolonged contraceptions, other co-infection with other sexually transmitted agents. Next slide, please. Well, previous to moving to talk about the prevalence of HPV-related diseases, I will explain a couple of things about the immune response, because I think that this will help us to understand the next slides and the differences between men and women. The natural response after a natural HPV infection is not very strong. After a natural HPV infection, most women seroconvert, but in men, there is less response to natural HPV infection. This means that fewer men seroconvert and the antibodies produced may not be protective. However, after vaccination with HPV vaccines, the immune response is high in both men and women, and the serological response to vaccination is much stronger than the response after natural infection. Next slide, please. Well, now I'm going to start talking about the prevalence of HPV-related disease, starting with the HPV prevalence in women. Next slide. Thank you. Well, in this figure, we have data from a large meta-analysis that includes more than 1 million women with a normal cervical cytology. Data suggests that at any given time, approximately 12% of women had a genital infection with any HPV type, including low risk and high risk types. As we can see, real data confirms the previous explained pattern of HPV prevalence in women, with the highest prevalence in younger women and a decrease thereafter. In the graphic on the left, we can appreciate this second peak in older women. This second peak is thought to be due to new acquired infection as a result of new sexual partners or the reactivation of a latent infection. It should be mentioned that the prevalence and age distribution varies by region. In the graphic on the right, we can see that the most frequent type in women is the HPV-16. Next slide, please. In this slide, we can see the distribution of the prevalence of the oncogenic types in women at the cervix and at the anus. As we can see in the graphic, well, the high-risk HPV prevalence is represented on the left, and the HPV-16 prevalence is represented on the right. Both prevalences decrease with age, both at the anus and at the cervix, although the decrease is highest at the cervix. Next slide, please. Less is known about the epidemiology of HPV infection in men. Next one. Well, a recent meta-analysis provides prevalence estimates of genital HPV infection in men. In this study, the global prevalence was 31% for any HPV, 21% for high-risk HPV, 5% and 5% for HPV-16. And as we can see on the graphic on the right, globally, HPV-16 was the most prevalent HPV genotype, followed by HPV-6. Next slide. Compared with genital infection in women, HPV prevalence in men remained high in young adults, and in men, the peak prevalence is observed between the ages 25 and 29 years, and then stabilizes or slightly decreases thereafter. This high HPV prevalence in men across the lifespan support that sexually active men, regardless of age, have a lower immune response to HPV infection and constitute an important reservoir of HPV genital infection. Next slide. A pool analysis published in 2021 investigated the epidemiology of anal HPV infection in men. The prevalence of anal HPV infection is higher among men who have sex with men and HIV positive men. The prevalence of anal high-risk infection ranged from close to 7% among HIV negative men who have sex with women to 74% among HIV positive men who have sex with men. HPV-16 was the most frequent type in the 4 groups. And well, we can see that the prevalence of anal HPV infection in men shares the same pattern explained in the previous slide, with high rates across the lifespan. Next one. Well, oral HPV infection. Next one. Data from a meta-analysis with more than 28,000 individuals estimates the worldwide prevalence in both men and women. Worldwide prevalence of oral HPV infection is 4.9%, with no significant differences found by sex. Prevalence of high-risk types is 2.6, and well, HPV-16 is the most common oral genotype with a prevalence of 1.0%. Prevalence is lower in the younger age group and then rises above the age of 40, with the peak prevalence among those aged 50 to 59 years. Thank you. Well, now I'm going to talk a little bit about the burden of anogenital warts. Next slide. 90% of anogenital warts are caused by HPV 6 and 11, included in the HPV, in the quadrivalent and non-avalent vaccines. And they are the most frequent manifestation of HPV infection in both men and women. But, well, data on the burden of these lesions among the general population are limited because anogenital warts are not notifiable and not a notifiable disease in most countries. Incidence rises sharply shortly after sexual debut, peaks at approximately 30 years old, and gradually drop off thereafter. Next slide, please. HPV, burden of HPV-related cancers. Next slide. Well, human papillomavirus-related cancer remain a major cause of cancer both in men and women. HPV accounts for 4.5% of all new cancer cases worldwide, comprising 8.6% of cancer in women and 0.8% in men, with variations between regions and populations. HPV-related cancers are significantly higher among women, and well, this is because approximately 80% of all HPV-related cancer cases are cervical cancers, as we can see in the figure on the right. Cervical cancer is the fourth most frequent cancer worldwide, although the majority of cases are diagnosed in low and middle income regions. Incidence of cancer that affect men and women, such as anal and oropharyngeal cancer, has increased. And in this figure, we have the total number of cases estimated for 2022, including both HPV-related cancer that are represented in blue and no HPV-related cancers that are represented in orange. We can see that thank you. We can see that HPV is responsible for almost all cases of both cervical and anal squamous cell carcinoma, but as it has been already mentioned, HPV also causes a significant fraction of other anogenital cancer and some head and neck cancers. Now, next slide, please. Well, this figure summarizes the contribution of HPV types included in HPV vaccines among HPV-positive cancer cases in both men and women. As we can see, most of the HPV-related cancers are caused by HPV-16, although with different distributions and differences by region. If we focus on the HPV types included in current vaccines, we see that particularly for cervical cancer, HPV genotypes 16 and 18, the two types that stand out for their greater oncogenic capacity, are responsible for 71% of cases, and the genotypes 31, 33, 45, 52, and 58 cause an additional 20% of cases. But as we can see, the contribution of these types is high among all HPV-related cancer sites. Next slide, please. And finally, as conclusions, we can say that HPV is a common infection, but most infections are asymptomatic and transient. A very small proportion of infection caused by high-risk HPV types will progress to cancer. The main determinant of progression is the HPV type, with HPV-16 being the most prevalent and carcinogenic type in both men and women. The prevalence of genital HPV in men remains high across the lifespan and supports that men are an important reservoir of genital HPV infection. High-risk HPV causes all cervical cancer cases and an important fraction of cancer of the vulva, vagina, penis, anus, and head and neck, mainly at the oropharynx. And finally, low-risk HPV types causes anogenital warts that are the most frequent manifestation of HPV infection in both men and women. Thank you very much.
Thank you very much, Beatriz, for your deep and interesting presentation. And I again encourage our participants to raise their hand after the second presentation with their questions, and now to prepare their questions and to use the chat for questions and comments. And now I'm very happy to give the floor to Professor Margaret Stanley, who will open her presentation, The Case of HPV Gender-Neutral Vaccination. Margaret, please.
The topic is the reaching equity with GNV. And just to recap a little on what Beatrice has just said, you heard enough about this HPV, a very common virus, but it's got two very important biological characteristics. One is absolutely species specific. So HPVs only infect humans. Rabbit papillomaviruses only infect rabbits. And it is strictly epitheliotrophic. In other words, its productive life cycle from infection to making virus will only take place in a fully differentiated squamous epithelium, or cells with the potential to do that. And you know about the distinction between low and high risk and the different types that are implicated in both. Now, if you're going to generate vaccines, you have to know what the natural immune response is. And the neutralizing antibodies, those antibodies that prevent infection with the virus, are directed against the L1 protein, which is one of the two coat proteins. And this extremely pretty picture of the virus, you can see a sort of shaving of loops across the top of each of these little rosettes that are studying the surface of the virus particle. These are the L1 pentamers. Each of these has 5 L1 proteins, and the loops you're seeing reflect the L1 protein in its tertiary or native conformation. And it's folded up like a wool in a yarn ball, and you've got these loops, and it's at the tips of these loops, which are reflected here, that I've got the neutralizing antibodies. And that's what makes this such an immunogenic virus. Now, we exploit this structure when we make the vaccines. So the vaccines consist of virus-like particles, and they only consist of L1. To do this, you insert the gene for L1 of the virus type you're interested in another microbe, yeast or the insect virus, baculovirus, and then it obligingly grows, because these viruses don't grow in tissue culture. But once you put the L1 gene into yeast or baculovirus, these microbes grow, they make huge amounts of the L1 protein, which spontaneously assembles into these pentamers, and they stochastically come together to form a virus-like particle, a mimic of the wild-type virus, but with no DNA, so they're not infectious. So, do these vaccines, why do we need these vaccines? Well, Beatrice has put very clearly that we have a big burden of disease. And so it's a potent carcinogen and causes multiple related cancers in men and women. I've shown you here the European data because we're talking about Protect Europe today. And you can see that the big burden is cervical cancer, but there is a huge burden of pre-cancers. And these are the things which actually cost money to treat and to remove. So this is a big burden of disease, and it's in both men and women. So what vaccines do we have? Well, we have vaccines that target HPV-16 and HPV-18 and these other types that are implicated in cervical cancer or benign cervical disease. And you can see, as far as cancers are concerned, this is a story of HPV-16. It is the bad boy. And wherever you are on the planet, at least 60% of cervix cancers will be caused by HPV-16. Of course, the prevalence in anal and oropharyngeal cancers is much higher. They are 16 caused cancers in general. Then the cervix is followed by 18, and then you've got these other types, which bluntly are bit players in the story. But if 16 and 18 together form about 70% globally of cervix cancers, but these other types taken together are 20%. So as Beatrice told you, the vaccines that encode only 16 and 18 will deal with 70% of cervix cancers, but most probably of anal and oropharyngeal cancers. But those that encode these other types will bring the impact of the vaccine on cervix cancer up to about 90%. And this, of course, underpins the reasons for the formulation of the current vaccines. And I'm showing you the commercially available vaccines in Europe. And you're familiar with them: Cervarix, which targets 16 and 18, Gardasil targeting 16, 18, and 6 and 11, and then the non-valent vaccine, which includes these other oncogenic types. And so theoretically, this should deal with 70%, 70%, and 90% of cervix cancers. They're given, when these vaccines were first being tested in randomized controlled trials, they were given in a schedule of 3 doses. And they were given to a target population of 9 to 26-year-old girls. 16, actually, let me rephrase that. In the trials, the population was 16 to 26-year-old women because the endpoint was disease, the precancerous diseases Beatrice has described. And they were given in 3 doses intramuscularly. And in immunological terms, this is a prime boost regime. You show the immune system the antigen early, and then you go in and you show it again. There's a response, and you wait for 6 to 12 months, and then you give a 3rd dose, which is to remind the immune system of what was happening, so that you get a very focused and increased response. Now, this stayed the schedule until 2014, when the WHO issued a recommendation that for those 9 to 15 years old, you could give a 2-dose delivery, 0-6 or 0-12 months. But for those over 15, it remained as a 3-dose. Now, we've had these vaccines in national immunization programs now since 2007, 2008. And so we have some good data now on the actual impact of these vaccines. Now, who were we going to immunize? When we put these vaccines out into the population, who was going to receive them? And initially it was given routinely to 9 to 15-year-old girls. And the reasons for these were this. First of all, they were licensed for 9 to 26-year-old females. But genital infection, as you've heard, is usually, but not always, sexually transmitted. And infection occurs very early after the onset of sexual activity. So since you're trying to prevent infection, you give it before they start their sexual lives. But there's an immunological reason also. The immune response to the vaccine is much better in 9 to 13-year-olds than in older girls and women. And of course, we were interested at that time mainly in cervix cancer. It was the most prevalent HPV-associated cancer. And therefore, if cervix cancer prevention was the rationale, girls-only vaccination was cost-effective. And cost-effectiveness is extremely important in national decisions for vaccination. Now, these vaccines have turned out to do exactly what we wanted. And this is the data which is coming in now from the Nordic countries, from England, from Scotland, from Denmark. And these are the numbers of cervical cancer cases in women under 30 who were vaccinated or vaccinated at different ages. If you were unvaccinated in the Nordic countries, they've had 94 cases per 100,000 women. If you were vaccinated at 17 to 30, when it's assumed you've started your sexual lifestyle, then fewer cases, but still 54. But if you were immunized before you were likely to be infected, there were 4 cases per 100,000. And in Scotland, if you were immunized at 13, there were no cases of cervix cancer in the under 30-year-olds. And cervix cancer is the second commonest cancer in women under 40 across the world, and probably in Europe. It occupies the first place in some countries. So this is a really important observation. However, why are we only giving it still to girls when I've shown you that this is a very potent cancer-causing virus in both men and women? HPV is what I call an equal opportunities virus. It doesn't care whether you're male or female. It's an infection. And so it infects a naive individual. It's not gender specific. And it's rising in incidence in men. And Beatrice referred to this. But these are the UK data from for oropharyngeal cancer from 1995 to 2016. And I want you to look at the red dotted line. This is in men, and this is the incidence of this cancer over time. And this is the blue dotted line. This is in women, incidence over time. And this is cervix cancer. We now have more cases of oropharyngeal cancer in men than we have cervix cancer cases in women. So men have a real burden. And of course, as Beatrice said, and I want to reinforce, prevalence of genital HPV infection varies in women, but it doesn't vary in men. Men make a lousy antibody response to HPV. Only about 20% of them make a detectable antibody, whereas 70 to 90% of women did. And these antibodies that men make don't seem to be protective. So they're not protected by their antibody, if they make any, and they're constantly reinfected. They get rid of it and they're reinfected, get rid of it and they're reinfected. So they are a source of infection for women. But if you vaccinate men, the vaccines actually protect against HPV infection and disease in men. I'll just show you a little bit of data on this. This is one of my favorite slides. It's an old slide, but it shows you pattern of infection in women, and this is from a study done in Manchester with actually a quite coarse HPV DNA detection. But you can see that there's this period of high infection in women. 25% have any HPV in the cervix. 20% have a high risk, but 10% are carrying HPV-16. And this declines rapidly over age, and they haven't got the blip in the over 55s. But you can look at this in two ways. This is may well be about partner number, or it may be about immunity. Women develop immunity. It may not always be protective, but they make an immune response. Compare this with men. The peak of infection, as Beatrice said, is more in their 30s than in the early adolescent period, and they stay infected throughout life, even in the 45 to 70-year-old age group. A friend of mine always refers to this as the Viagra effect, but perhaps we won't go there. And now, vaccination does protect, and these are the two trials that were done in men to establish the efficacy of these vaccines in men. As you've seen, men who have sex with men have a very high prevalence of infection, and they have a high incidence of anal cancer and the precancers that lead to this anal intraepithelial neoplasia, and these are the high-grade anal precancers. They were immunized either with Gardasil or with a placebo. And as you can see, those who were immunized with the vaccine showed efficacy against these precancers. Against genital warts, again, in men who have sex with men, there are very high incidence of genital warts and a very strong efficacy. So if you want to protect a man, you've got to vaccinate him. That's the message very clearly from this. But you might ask questions then. Okay, if we're going to give 9 to 13-year-old boys this vaccine, do they make as good an immune response as girls? Well, yes, they do. The yellow are men or boys, 10 to 15 years of age. The green are girls, 10 to 15 years of age. And the orange are women, aged 16 to 23, in whom efficacy has been demonstrated, remember? Now, the boys make a better immune response than girls, and girls and boys make a better immune response than 16 to 23-year-old women. And this response starts to go down after puberty. After puberty, it's downhill all the way. The other question you might ask is, well, all right, if you vaccinate them, does it persist? Will the duration of protection in men be the same as in women? And this is a paper in which they followed up the men who had sex with men and were vaccinated in this phase 3 randomized controlled trials, which I've just shown you, and the vaccine provided durable protection over this 10-year period. So boys make an excellent immune response, and the protection they get from the vaccine remains. So why aren't we immunizing boys? Well, it's the rationale is this. Men who have sex with women get herd protection if girls only are vaccinated, if the vaccine coverage in women is high. And in the analysis for cost effectiveness, that means that it's not cost effective just to immunize men. But men who have sex with men are not protected by female-only vaccination. They could be vaccinated as a high-risk group, but there are other groups which are not protected without a very high female coverage. And those are marginalized groups, migrants, men who frequent sex workers. There's a whole list of of these marginal groups who do not receive protection. Now, the cost effectiveness story is a modeling story. And one of the things that's important in modeling is, what is the question you're being asked? If you're looking at cost effective, you need to use real world data. And this study, which is a European study, looked at this very carefully. They included the costs of non-cervical cancers. They used real world data for vaccine uptake, not the targets that were set. They used a 2-dose, not a 3-dose program, and now a 1-dose. And they assumed tender-based dose prices. That means that a country will put in a tender and get a discounted price because the volume of vaccine it's buying is so much lower. And when their model showed that the incremental benefit of gender-neutral vaccination compared to girls only was cost-effective. So the cost-effective argument doesn't stand for the European situation. No. I want to say also something really crucial. Herd protection is not herd immunity. Now, men who have sex with women, but not men who have sex with men, get herd protection from female-only vaccination. But the coverage has to be high. I've given you 60 to 70%. It's actually more like 80 to 90. And this coverage has to be sustained. You have to maintain your vaccination rates in women at 70, 80, 90% year after year after year after year if you're going to protect non-vaccinated individuals. And the reason for that is quite simple. With female-only vaccination, men are not immune. They're protected if their sexual partners are immune or not infected. But if you're only immunizing half the population, and of that half, only about 2 or 3 in 10 are being immunized, then you've not got much protection. Herd protection is not herd immunity. Herd immunity is when everybody has either been infected and had an antibody response or who's been vaccinated. And so by definition, female-only immunization cannot give herd immunity. And there are risks for marginalized and minority groups. And this comes down now to equity. Here you have men who have a burden of disease, who are protected if you vaccinate them, who could be vaccinated with a highly effective vaccine, but we're not giving it to them. That is not vaccine equity. So what about gender-neutral vaccination? Why do I think this is required? Well, first of all, they directly protect against HPV infection and disease in men. And we've gone through the fact that men are not protected by natural antibody. They're constantly reinfected, and they're a source of infection throughout life. Now, equity is critical in this debate. If you immunize before the onset of sexual activity, you've protected all men. Doesn't matter what their sexual preference is, what groups they belong to, what their lifestyle is, they are protected. And program resilience, this is not something that we've discussed before, but if you immunize girls only and there's a vaccine scare and the coverage drops suddenly, then the impact is very much reduced. But if you immunize boys and girls, there's a solid protection in that, and the resilience protects against the drop in coverage. This has been shown by modeling, but it is very clear. And then popping transmission, you get this vaccine because you're infected from your partner. As I keep saying, it takes 2 to tango. And so you have to block transmission. Blocking transmission is essential for maximum disease impact. And you achieve that by immunizing boys and girlies. That gives you the true herd immunity. Now, this is understood, I think, by public health authorities. And in Austria, which had the first gender-neutral vaccine program in the EU, this is stated in their website. The vaccine was included since 2014 in their program for girls and boys in the 4th grade class. Gender-neutral vaccination has high epidemiological benefit because it is the only way to break the chain of infection. And to quote from the paper that Beatrice referred to, the meta-analysis from Bruni and colleagues, this is their one of their final paragraphs. And they point out around about 1 in 5 men are infected with 1 or more high-risk HPV. The prevalence is high in adult men, and it doesn't matter how old they are. If they're sexually active, they remain an important reservoir of infection. And so it's important to incorporate men in comprehensive HPV prevention strategies. Protect Europe is about preventing HPV-associated cancer. Without gender-neutral vaccination, you don't achieve that. So the burden is almost the same as in men as in women. They face a rising risk of disease. They make poor immune responses. Without vaccination, they're at risk. They're vulnerable to the development of HPV-caused cancers. This is not equality. This is not equity. Without GNV, all these things apply. There are no cost-effective or reliable methods, screening methods, for non-cervical HPV-caused cancers in men and women. So GNV is crucial to prevent them. If you use GNV, immunizing boys and girls, you get real herd immunity, you block transmission, you get a rapid reduction in virus prevalence, and that's essential for impact across the population. So without gender-neutral vaccination, elimination of all HPV-caused cancers will not be achieved. Thank you.
Thank you, Margaret, for a very clear and straightforward presentation of what should be done to have maximum effectiveness of HPV vaccination. So now I'm opening the floor for questions. Please feel free to raise your hand or to write your questions in the chat. And we have already a question in the chat from Irfan to Professor Stanley. Could you please share a brief insight in oral HPV cancers, as there is an increasing incidence globally, and also your insights on vaccine hesitation from some groups?
Sorry, I'm lost.
Well, the first question is, could you please share a brief insight in oral HPV cancers, as there is an increased incidence globally?
Well, the increase is seen, and Beatrice perhaps can answer this question better than I, but in high-income countries, I mean, this was first observed in the Nordic countries, in Sweden, and Finland, and in the USA, and it was because 20, 30 years ago, we hadn't really seen HPV as a cause of oropharyngeal cancer. So it's rising in high-income countries, so across Northern Europe, in Japan, in Australia. But the data from other countries is really very limited. And as I say, I think Beatrice can answer that perhaps better than I, what the incidence data is globally.
Beatrice, would you like to join?
Well, what is known is the incidence of head and neck cancer varies a lot by region, and it's highest among high-income regions. It has been, we see that the incidence of head and neck cancer is rising in high-income regions. And also, it's important to say that the attributable fractions, which means the percentage of cancer cases that are due to the HPV infections, also varies a lot through region. In some region, there is a 10% of head and neck cancer, or particularly I'm talking about the oropharyngeal cancer. But in other regions, they achieve number at 70% in some countries in Europe and in United States.
I think that it's important to say that the oropharynx is different to the cervix. So if you're looking at it from a mechanistic point of view rather than a public health point of view, then the mechanism of neoplastic change is probably different. And we also, I think, are not really very well informed on the immune response to the virus at the tonsil and base of tongue sites. So head and neck is an area of intense research. And it's a very interesting area to work in. But I think the message for what we're talking about today, which is trying to prevent HPV-associated cancers at any site, is as clear as can be. You really have got to immunize your population, and that doesn't mean that you distinguish between boys and girls or men and women.
Thank you. Also, the second part of the same question was, can you share some of your insights on vaccine hesitation from some of the groups?
Well, again, I think you can't apply global comments on vaccine hesitation, because the reasons for accepting or not accepting vaccines often are culturally determined. What the tradition has been. I mean, for example, in France, there's been a lot of resistance to vaccines for reasons of vaccine scares in the 80s, whereas in the UK, we were very concerned that there might be backlash against HPV vaccines. But because we had a measles scare, there was a lot of effort put in to informing people before the HPV program was introduced about the vaccine, about the safety, about the fact that it really was important to stop girls getting these precancers and cancers in their old age. But vaccine hesitancy is a really important factor, because it's not just high income countries. You see vaccine hesitancy in low income countries, which you would think would be absolutely unknown, but it's not. And that's about fear of the unknown, the ability to spread comment and opinion and frankly gossip via social media has harmed this whole public health intervention significantly. So why are we frightened of vaccines? Well, because it's unknown, and because we haven't got an acquaintance with the disease. You will take a vaccine if you have first-hand knowledge of the disease. So the more successful we are with vaccines, and we lower the disease incidence or abolish it, then people think, oh, it's gone. Don't worry about
We
that.
forget how frightening it is.
Yeah,
This especially.
I want to add one thing.
Yes, of course, Beatrice.
It's important to remark that I think it was in 2019, the World Health Organization marked as one of the top 10 priorities the vaccine and the anti-vaccine groups and the hesitancy. So it's really important to make people know about the vaccine and try to get the most people vaccinated.
I think if you're going to introduce a vaccine into a population, you have to prepare them. You really have got to have an information program. And that information program should not be dictated by the scientists or the public health physicians. You need people who really know how to communicate and communicate with laity, with you and I, where we're going to receive a vaccine. You should go on your own instincts. If somebody, if there's a vaccine and it says it causes this, this, and this in children, and I don't know anything about it, I will feel frightened. I will think, I'm not going to allow my child to have this. So before vaccines are introduced, you have got to give the public the information, and it has to be given in ways which are understood, and that means using skilled communicators.
Thank you, Margaret, because we have a lot of questions and we're running out of time. We'll take another question from Nadia. Should people over 40 years old get vaccinated? And should one be vaccinated if one already have HPV infection? Would it be effective in some way?
Well, from an individual point of view, yes, there is no evidence that you're going to do any good, but you certainly aren't going to do any harm. So often one is asked, my partner has this, or I have head and neck cancer, I've got oropharyngeal cancer, and is HPV-16 positive. Should I be vaccinated? Should my partner be vaccinated? My response to that is exactly what I've said. I have no evidence it'll do you any good, but it won't do you any harm. And it may well actually do them some good, because there is some evidence that if you immunize someone who is shedding virus, the antibodies which you generate will be certainly in the cervical mucus and may well neutralize that virus and prevent it being infectious to whoever you're having sex with. So, but that's not solid evidence to date.
Thank you, Margaret. And maybe one really last question with a short answer. Is it known why men have such a lower immunity response compared to women? And then I'll thank you and pass the floor to Professor Daniel Kelly to close the masterclass, and we'll have more of these masterclasses. So please keep informed from ECHO for the next opportunities.
Well, I think the answer to the question is we don't know, but one could speculate that the first site of infection for men is usually a very heavily keratinized surface. And I think it's a question of access of virus to the immune system. Plus, there may well be other factors, but we simply do not know. But men and women do not respond to antigens similarly, and particularly in to sexually transmitted infections.
Thank you, Margaret. Thank you, Beatrice, and thanks to everyone who was part of this masterclass today. And Daniel, up to you.
Thank you, Plamina, and thank you to both our speakers today. I think it's an incredible opportunity for people to join just for 1 hour and to hear such expertise on show. We will have more masterclasses. That's the point of Protect Europe, is to share the knowledge that I think people need in order to influence their own country's policy towards these issues. For me, one of the major challenges is that HPV, of course, is related to human sexuality, and that can become a huge taboo when talking to the public. And as Margaret alluded to, cultural values also impact. So that might be something that we need to come back to in future masterclasses, because the science is one thing, but making it happen in reality is quite another. And that's what Protect Europe is seeking to achieve, is to influence and provide information. Please do visit the Protect Europe Hub. The link has been put in the chat. And please do look out for future masterclasses, which should be coming very soon. So it just remains for me to say thank you to both our eminent speakers today. Thank you to the European Cancer Organization for organizing. Thank you to all the stakeholders in Protect Europe for making this possible. And final word to our CEO, Mike Morrissey. Thank you, Mike.
Well, thanks, Danny. What an impressive first masterclass that was. I was sitting here in Zagreb, where I'm working on HPV activity here, and super impressed. I learned a lot, having worked in at ECO on HPV for 5 years now. I'm still learning every day. So thanks very much to our excellent presenters. Thanks to all of you for being here. Thanks to the team in Brussels, particularly Sylvia, for coordinating everything. And we look forward to staying in touch. We put in the chat there how to get involved with our network, how to look at our Protect Europe hub of information, how to contribute to our Protect Europe hub of information. It's great working with all of you, and let's continue this journey together. You'll find out more about our masterclasses very soon. Thank you very much indeed.